Hello everyone, this is Caplitero and welcome back to a new episode. Today we're gonna talk about Sfml once again, like we usually do, because that's everything I know. And as you may have seen on my channel, I've published a cube that rotates and uses a value noise texture. And yeah, that's what I wanted to show you guys today. It's very, I hope it doesn't take too long, but we'll see that. Um, First of all, a new Sfml template. This will be I don't know, value cube. Can I do that? Okay. Um, I'm gonna use this, and we'll go to my. Let's go here, here, and in my GitHub. You already know this one. Can I shortcut? No. So I'm gonna bep 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 better. What is called very noise. Okay. This and because I want window class row, and we go in here, copy, paste. This will create the value class value. This should work. Come on, Visual Studio. Okay. And this should work. Yes. No, because this will calculate every time. It takes too long, and the um the algorithm goes through the whole cube, and that's bad because not here. In here, in 3D, we can see that it goes through all the points, and we just want the faces. We don't need to calculate everything. So how you do that? Go to value noise and I'm gonna create a new function. Let me have it right here. Value noise cube value class. Okay, so why am I doing this video even though I've posted the GitHub project? Well, I just want to explain how this works. I don't know, it was a lot of hard work, and maybe somebody wants to work, I don't know, use my code and doesn't understand one part of it. I have to explain it, and I like it. So I'm gonna call this a float value, let's say 3D transformation. Or actually is just XYZ. And was this? It's this bad boy from here to here. I don't think it has. Oh. So is the 3D interpolation. Nothing new. We have octaves, the size, and after this we're gonna return noise divided by f scale. Did I forget anything here? Of this, I'm gonna use just a 4, and I hope this is all for this. Is, instead of going through all of those points, we choose a point in space z, I x, x I z, and gonna calculate the interpolation for that specific point. Okay, so what are we gonna do with that? Let's put this. Is this in? No. Put this in private. Potentially need it in public. And now I'm gonna transform the cube. A void. This is called transform cube 3D. Transform. It's just like draw, like we have here. Transform seed, but this is for a cube, so yeah. Okay, so we're gonna have 6 faces. Front, back, left. We're gonna find them and calculate them. Well, gonna have x. Let's actually copy them. Okay, so we're gonna move through the z, x and x and y, I mean. And why we do that? Let's say paint, because if I'm moving through the x and I can say a specific z, so z is a start. Because this is z0, and say this is z equals size x. I'm sorry, this doesn't even say size, but okay. So we can specify x and y. So we go here, 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 here on the z. So on the first phase, this is the front. The last one is the back, but the back will be rotated because we don't go left to right, we go right to left. So we're gonna do that. Output of 0 x plus I times size x equals value transformation of x, y, and the first one. So this is the front. Okay, what is output? Right here, we're gonna have a float of double pointer output. Why double pointer? Because it's gonna be a 6 by size of x. But because size of x is not defined, we're gonna put this, and in the creation we're gonna have let's say output equals new float of 6, and we're gonna put a small pointer, and now for every int I equals 0 I 6 I plus plus, output I equals new float size x. It's a cube, so every side will be the same length. I hope I did write this. Okay, yeah. Size, everything is the same. Anything else? I don't think so. I have right here, delete the data. Anything else? Let's go back to our transformation cube, and we're gonna have one more output. This new output will be the back. Oh, will be the back. So we're gonna say output, and this will be kind of complicated. We go from, I told you, from right to the left. So we're gonna have size x minus x, because you start from the right side, minus x, and we'll have a minus 1 because the size of x stops 1 4, plus I times size x. We're gonna have two more of them. From this, we'll say front, back. What else do we have? Front, back. And this will actually be size of z, size z minus 1, because we're at the last point, at the last facet in the back. This is size z minus 1. Next, we're gonna move to x and z axis. So we're gonna change just our y. So we're gonna move 0, this one, and the last I is this one. We're gonna have 0 and the size of I minus 1 on the last one. So how we're gonna do that? Have new face. This will actually go from left to right, like actually usually does. And size x, because it doesn't change. Size x. Okay. And it does change here. And size y minus 1 z. Anything else we're gonna have? So this is up, up and down. We're gonna have left and right. In the left and right we have the x coordinate that doesn't change. So this is the x coordinate and this is the last x coordinate, so we say right. Okay. So x doesn't change, x, y, and z. X, we don't have x. I'm gonna have 4 and 5. 4 and 5. This will be z plus I times size x, because it goes from right to left. And this actually goes the opposite way. Size x minus z minus 1 plus I times size x. 0, and it will be inz size x minus 1. This is everything and very nice. I hope so. I don't think I've missed anything. So we have this transform, very nice. Left and right. Let's see if I missed anything. We don't want any problems with the code. X. I hope so. Um, now let's check if this has any problems. Yeah, the problem inz is actually zip. And anything else expected equals. Okay. We have to check sometimes we miss anything, so we'll have a real problem later. Sometimes Visual Studio just like loves to play with you and makes your day harder. Okay, we're gonna go back to our window class, and this is the fun part because this is a lot to write. So I'm actually gonna this and go up here. Okay. Draw vector. Let's say I don't think I actually use this mouse to use this map, and we're gonna use this big boy later. So what are those? Those are the positions for 6 faces with 4 points. 1, 2, 3. So those are the points. What else do we need? Because we're gonna calculate the points and we don't use all faces at the same time, we use maximum 3 faces of the cube. So what are we gonna do with that? I'm gonna use this. What else are we gonna use is the map position, the mouse position. These positions, the mouse. This will be the output for cube. This will be mouse position start and mouse end for the cube. Anything else? Cube faces. This will be render texture faces. We're gonna create. We can't convert points directly. We have to draw to render texture and then draw to the vertex array or window. No, create a texture and draw to the window. Because you can actually have a vertex, let's say here, this is the vertex and add texture. It will be and convert the texture depending if you set, let's say, map to of 1 dot. You can see text coordinates. These are the coordinates in the texture. You can have a picture and just set the coordinates from 1 point in the cube in the picture. What else are we gonna use? We're actually gonna have include of cube, but I didn't add cube, so new I have cube and the cube, it's something easy to make. This will not change anything about this because it's a cube. We move the cube and that's it. Let's include cube. Um, smart enough. Okay. And we're gonna have a cube. Okay. We're actually gonna have a cube. No pointer. Let's actually add it here. So position Z, a float of draw vector, null pointer. This will be part of drawing. Anything else? I don't think so. I'd say this will be cube 3D. No. In the update draw, I'm gonna have two loops. The first loop will initialize all the faces. So for int g equals 0, g more than 6 plus plus. So all the faces. Gonna have two loops from 0 to tile wide. So every face will be a quad with same length. The index window will change depending on, so I times 6 gonna have 6 faces, so we're gonna this will be the face of the cube, let's say, and on the same vertex we're gonna add the new window, the new one. I'm gonna have 6, so 1 2 3 4 5 6, and the total length of this will be the size times 6 to have a straight line for every point. And because I'm gonna move every time to the right, we can jump this position and go one more. So this will be size of x. I'm gonna jump size of x. So plus size of x, the tail width, tail width times j, because we jump the tile width times tile j. So now the ID texture will change to tile width. Oh, tile width plus x. So the cone doesn't change. Let's not change the color. The map to the color. Actually, I actually had, why did I map to the okay. After we've drawn to the vertex, we can actually convert the faces clear and faces, draw map to the, and right here in the initialize, let's do it right now so we don't forget about it. So we have a new window, a new map, and a new cube. Cube equals new cube, let's say 300. It doesn't matter, you can make it 5000. It will convert the faces. Sfml will do it for you. Cube 3D, set primitive to SF quads. You can actually move the cube, and let's move it and draw it to the middle of the screen. You already knew what this position can best be set to 0. It doesn't change anything, but it's 1. What else? Cube 3D will be resized to cube show size times 4. And faces create face with the tile width times 6 and height. We're gonna create a picture with the size of 6 pictures, 6 vertices. I'm gonna draw to every one of them and we'll convert it to a texture. When we finish, map to set primitive points times 6. We're gonna have 6 faces. Map, transform map. Okay, we're done with that. We'll go back to our update draw, and for int equals 0, whoa. So for every face, we're gonna have a face ID. You already knew this. It's from the cube, so we draw the faces. So we're gonna start with face 1. Every face will have a space in the cube 3D. We're gonna have 3 faces. I times 4 means the first. We're gonna have 1, 2, wait, it's 0, 1, 2, 3. This is the first quad, and then we're gonna have 4, 5, 6, 7 times 4. Okay, now for int j equals 0, j more than 4 because we have 4 corners, j plus plus. We're gonna check every corner and we're gonna get a ID equals face ID, and we're gonna convert depending on the ID. With the ID, we have it right here. With this, well, every face will, I already wrote it here. Every face has one, let's say the front is 0, 1, 5, 4, 0, 1, 5, 4. And I want to know what is this face. This face will always be the front. and the front has a value of 0 because I made an enum, so front is 0, right, and depending on this we can write it here because we actually add this right here, but we lose the place and that's bad. So we have a way of knowing what phase it is. In the update, we're gonna have SF render text render state faces display because we want to update the faces, and states what is it, texture equals faces get texture. And now we can draw the cube 3D states. But cube 3D is updated more exactly in what do I update cube 3D, because I know it doesn't update. Let's see if I actually see the cube. Yeah, this is the cube. And I want to move the cube. So in here, we're gonna have our last, you guys already know this. I implemented it in the cube. In the cube video, you can move the cube. Okay, undefined 1 second. It actually goes here, bool of okay, a equals 0. And now okay, so this is the face. But it's weird because I'm not updating cube 3D. It must have been in update draw. Position. Oh, I'm having the my brain hurts a little. Yeah. So here I'm updating the cube. So the problem J vector of int cube 3D times 4 face J plus plus. Okay, so what's the problem, mi amigos? must forgot to update the cube, didn't I? Event, update, transform. 1 second, guys. Okay, guys. There were some minor problems, something real fast to solve. So, first of all, output will be an image, not a array. Like I said the first time, I only said size X, but it's an image. So you'll have a z-axis, but it's the size of X pixel because it's a cube. This is all here. In here, we're gonna have del with del 6. What else did I not mention? Transform cube 3D because we are not gonna use the normal 3D transformation. Gonna specify for the cube. Here, like I said, texture, states. I didn't change anything here. And here the position updates, so X plus position X. So let's say, oh, not this. Let's say I have, this is the image. This is the image. And I started with the first image. Let's go to the second image. So you're gonna have X plus then 0, let's say, plus I. So this is xi. Uh, and this is actually the first position of the cube that I mentioned here. So the face 0, 0, 0, the first location. And if I didn't lose my way of thinking, so create a new map, new cube, move it, create a cube. Let's no take this, put it here. More space to breathe, so we can get them in spaces. Let's say we can call this initialize world. This will move and draw cube. This will initialize the cube vertex X array. Create new image for texture. Generate new value noise map and initialize texture vertex array. You know that this is moving the cube. This is contracting, adding new position. Actually, don't need this. Octaves, minus octaves, noise cancelling. So minor changes. This is drawing with the states. Here we're gonna have find of all corners coordinates. And if we now go to this, we're gonna have our cube. Let's change the, oh, and now if we look, everything is connected in a nice way. And make up, and this is the cube. We can actually, as I told you, we can make the cube as large as we want. Let's say we wanted to make this no, what size? Let's say this, and make the cube the size of 5. Let's not forget that the bigger the cube is, it will be nearer the view, and you can see that there are no problems. I need to check on these lines. It's a small problem. This is caused by a very small misaligned. I think I missed one X somewhere, but you can see everything is working and we can generate new maps. The colors can be changed. Where did I write it? Here. The colors can be changed here. So let's say I wanted it to be red and blue, violet. And I think that I can, let's say, if I wanted to rotate here, let's say I wanted to rotate it every time, I don't know, I have to draw, yes. Let's say I wanted to rotate it here with a small 0.02, let's say 0.03, and after that we're gonna do this. Let's say this depends on the frame rate, but you can see it is moving on its own, like with full, and you can change it while rotating. You can see a small wait time because it's generating a small bigger number of points. We're calculating just a fraction of them, but we need to generate a whole cube of points. So we get this, oh, this linear pattern. But the way it converts is quite easy. So I hope you guys actually understood. Let's save this. Actually understood. uh, I've actually understood. I'm working on my English. I'm sorry. Um, but yeah, I'm trying to do something, like I said, interesting, and this was a big project for me. It's for you guys, maybe it's something small, but for me, it was stressful, and it took me a long time to understand everything. I had a lot of research done, but it's done, and I thank you a lot, guys, for watching. We'll have I have many ideas, and I work I'll work for something new in a few days. And once again, thank you for watching, guys. Maybe leave a like, subscribe, and see you next time.